Let us look at some algebraic identities. Okay, these are like the building blocks of mathematics. Everybody should be thorough. You may be writing CBSE, ICSE exams, 10th class, 12th class, or even at the engineering level or IIT level. If you don't know this, they will start committing mistakes in this. So I will start with the most basic, a plus b whole square. This we would have covered it in class 7 or 8. But I will tell you a little bit of combinations and some special cases in each of them. So a plus b whole square will be a square plus b square plus 2ab. Okay, so this you should look at it as the first term square plus second term square plus 2 into first term into second term. That's how you have to do it. Suppose I have a case like this, minus a minus b whole square. Okay, this formula is not there, but what you have to do is you take minus sign common, or when you take minus common it becomes minus 1, then inside the bracket it becomes a plus b whole square. The square will apply to minus 1 also. So when you have put this square, it will be applicable to this also. Okay, so minus 1 square, minus 1 into a plus b whole square. Minus 1 square is 1, minus 1 into minus 1 is 1, and this becomes a plus b whole square, which is the same formula as above. So minus a minus b whole square is equivalent to this. You should always remember that. Okay, let's come to the next identity. A minus b whole square. That will be a square plus b square minus 2ab. Okay, so this is the first term square, okay, plus second term square minus 2 into first term into second term. That the reason why I am telling you in terms of first term and second term is because when you have complex cases like say 4xy minus 3x square y, something like this, so you have to take the entire term of this. So this becomes 4xy whole square plus 3x square y whole square minus 2 into the first term into second term. You multiply them and simplify them. Okay, here you have another variation. This will also I'll discuss over here. Okay, suppose you have a term like this, minus a plus b whole square. Okay, these things will not be there in the formula. Okay, for everything we cannot have a formula. Okay, you have to get it to the standard formula. So what we do, like the previous identity, take minus sign common. So this becomes, when you take minus sign common, the signs get inverted. For example, if I take minus sign common of a minus b, it becomes b minus a plus b, that becomes b minus a. Okay, that you have to remember. The signs become reverse. So when I take minus sign common over here, this becomes a minus b whole square. So if I apply the square to even the minus sign, okay, this negative becomes plus and this becomes equivalent to this. So minus a plus b whole square is nothing but a minus b whole square. Okay, you should keep that in mind. Let's look at the next identity, a square minus b square. I'm sure you would have done this also in your lower classes, something like 8th or 9th. That will be a plus b into a minus b. Okay, again this. So some example like that would be say 9x square minus 16 by y square. Okay, that will be equal to 9x under root will be 3x, 16 by y square will be plus 4 by y into 3x minus 4 by y. 16 by y square under root will be 4 by y. Okay, something like this. Let's look at the next formula. A plus B plus C whole square. A plus B plus C whole square. This is also very important. Will be equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Okay. In this is a very confusing formula actually. You will never be given A plus B plus C whole square like this directly in the exam. You will be given with some variations like A minus B plus C whole square. Now there are multiple variations to this formula and you cannot remember a formula for each and everything. So what you have to do, you have to remember the base formula and then do the adjustments of these variations as per the problem. So what I will do over here is, instead of A minus B plus C, instead of minus B, I will write this as A plus minus B plus C whole square. So here again, like I said, this is the first term, this is the second term, and this is the third term. Okay, so this is first term square plus second term square plus third term plus 2 into first term into second term plus 2 into second term into third term plus 2 into third term into first term. That's how you have to remember this. Okay, so instead of A plus B plus C whole square, you have X plus Y plus Z whole square. Then also you apply the same concept of first term, second term and third term square. Why I am telling you first term, second term and third term is, here the second term becomes B minus B, not B. Okay, so here you have to apply all formulae according to taking the second term as minus B. So that will be first term square, that is A square, second term square, that is minus B square, but minus B square and B square are the same, so you simply write it as B square. Okay, plus third term square C square plus 2 into first term into second term. 2 into A into minus B is minus AB, not AB. That's where we get the difference. So it becomes minus 2 into AB. Okay, plus second term into third term. Minus B into C is minus BC, not plus BC. So that becomes minus 2 BC. Then you have 2 into the third term into first term. Here it is, there is no change of sign. So that becomes simply plus 2 CA. This is how you have to remember it. Okay, so I hope it's very clear, because all the student gets confused at this point only. Instead of minus B, how you have to vary it, just instead of B you take a minus B and apply the same above formula. Now for example, suppose instead of this you have, say, let us change the formula. Instead of minus B you have minus C. You have A plus B minus C. So again you should write this as A plus B, there's no change, plus minus C whole square. Okay, so the third term becomes, instead of C it becomes minus C. So apply the same formula. First term square, that is A square, second term square, that is B square, third term square, that is C square, plus 2 into first term into second term, that is 2AB, plus 2 into second term into third term, B into minus C, that is minus BC, so that is 2BC, plus 2 into third term into first term, minus C into A, that is minus CA, so minus 2CA. Okay, hope that's clear. Okay, again we can have one more variation. Instead of suppose you have something like this, minus A plus B plus C. Instead of taking A, you can take minus A, that's one method, whole square, or what you can do, you can take minus sign common, then it becomes A minus B minus C whole square. Okay, this is also one variation. Square of minus will be positive, so that you can ignore. Okay, so remember this, A minus B whole square is same as B minus A whole square. This is another important point. In algebra, all these things make a lot of difference. You should know these things. Okay, so you have this A minus B minus C whole square. Let's do that formula also. Suppose you have a minus b minus c whole square. Okay, instead of b you take minus b, that is a plus minus b plus minus c whole square. Okay, so here the first term is a, second term is minus b, third term is minus c. So square of the first term a square plus square of the second term minus b whole square is b square plus square of the third term c square plus 2 into first term into second term, a into minus b is minus ab, so that becomes minus 2ab. 2 into second term into third term, that is minus b into minus c, that becomes minus into minus plus bc. So that's where you've got to be very, very careful, because this is the point where students commit mistake. So 2 into second term into third term, minus b into minus c plus bc, so that becomes 2bc. Okay, plus 2 into third term into first term, minus c into a, that becomes minus ca, so minus 2ca. This will be the answer. So I think I've covered all the variations of a plus b plus c whole square. Okay, you have a minus b plus c, you have a plus b minus c, you have minus a plus b plus c, that can be converted into a minus b minus c. So all the variations I've covered. Let's look at the next formula. Squares are done, we can look at cubes. A plus b whole cube. A plus b whole cube, that will be a cube plus b cube plus 3ab into a plus b. Okay, this can be expanded and or written in a different way, that is a cube plus b cube plus, when you expand this using our distributive, 3a square b plus 3ab square. This way also you can remember, either one of the formula you can remember, both are correct. Okay, here again, suppose you have something like this, minus a minus b whole cube, then what I do, like in the previous squares, I take minus n common, it becomes a plus b whole cube. But here the problem is minus 1 cube is not plus 1, so here it will make a difference. So the minus 1 whole cube is minus 1. When you have odd powers to minus 1, it becomes minus. When you have even powers to minus 1, it becomes plus. So because 3 is an odd power, minus 1 whole cube will be minus 1. So we will have minus sign preceding to this, and then you have your a plus b whole cube. As usual, you expand it. Okay, that is a cube plus b cube plus 3ab into a plus b, or 3a square b plus 3ab square. That way you can do it. Okay, let's look at the next identity. A minus b whole cube, that is a cube minus b cube minus 3ab into a minus b. Again we expand it, and the equivalent form will be a cube minus b cube minus 3a square b plus 3ab square, because this minus and this minus, when they get multiplied, becomes plus. Minus into minus plus. You have got to be very careful. This is where most of the students commit mistake. They write it as a cube minus b cube minus 3a square b minus 3ab square, and colors, all your marks are gone. That's where you've got to be careful. Again, a minus b whole cube. Suppose you have this minus a plus b whole cube. So again I take minus n common. You write this is minus 1. Okay, whole cube into a minus b whole cube. So to this particular formula you apply a minus sign and expand this a minus b whole cube. So it will work out. The minus sign is outside, so as if you're putting a minus sign over here. So this is a minus b whole cube. These identities you have to be perfect because maths, trigonometry, calculus, everywhere will use these identities. Let's move to the next formula. A cube plus B cube. This is also very important. This formula is used extensively in trigonometry, algebra, calculus, integration, differentiation, everywhere is equal to A plus B into A square plus B square minus AB. Okay. This one also can be written as, we can use this basic formula, A plus B whole cube is equal to A cube plus B cube plus 3AB into A plus B. Now you keep this on the RHS, send everything else to the LHS. So this becomes A cube plus B cube is equal to A plus B whole cube minus 3AB into A plus B. You can also use this formula, and this also has some specialized uses. So either one of these two you can use. So either you can use this one or you can use this one. Okay, this is nothing but the different form of the previous formula, so you don't have to worry remembering that. Okay, but this one you have to remember. This is very important. I'll again give this formula. A plus B whole cube, sorry, A cube plus B cube is equal to A plus B into A square plus B square minus AB. Okay, this have to be by hearted, committed to memory. Let's look at the next formula. A cube minus B cube. Okay, many times in integration and all you have sine cube theta minus cos cube theta. Okay, you have to integrate divided by sine theta minus cos theta. People who have studied the higher calculus, they will know these kind of formulae. So that time you can expand this and cancel out. It will be useful for these kind of scenarios. That's the reason I'm showing it. Okay, so A cube minus B cube is A minus B into A square plus B square plus AB. There is no 2AB, you have to be careful, plus AB. Okay, A cube minus B cube is equal to A minus B into A square plus B square plus AB. This is also very important formula. It has to be committed to memory. Let's look at another very important formula. A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. This formula is extensively used in government exams, GRE, GMAT, competitive exams, all these kind of exams. Okay, why, I'll let you know. Okay, just remember the formula, understand the formula. A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Okay, just imagine a situation where A is, say, where A plus B plus C is becoming 0. Okay, 0 into this entire term becomes 0, the RHS becomes 0. So in that kind of scenario, A cube plus B cube plus C cube becomes equal to 3ABC. That means the cube of three numbers, the sum of cube of three numbers becomes equal to 3 times the product of the three numbers. That is where this particular shortcut is used. Okay, which we'll see more in deep when we'll do some practical examples.